Ocean tides are caused by the moon's gravitational pull. But why does the water also rise on the side of Earth that faces away from the moon? While both the moon and the sun influence the ocean tides, the moon plays the biggest role. Although the sun's gravitational pull on the Earth is 178 times stronger than the moon's, the tidal bulges it causes are much smaller. This is because, contrary to common belief, tides are not caused by the gravitational forces of the moon or the sun lifting up the oceans. Their gravitational pull is much too weak for that. Rather, tides are created because the strength and direction of the gravitational pull varies depending on where on Earth you are. This variation creates the differential forces or tidal forces that in turn cause tides. The tidal forces of the moon are much stronger than the sun's because it is so much closer to our planet, causing a much greater variation in the gravitational force from one location to another. The sun's gravitational force, on the other hand, varies much less because the sun is so far away. The overall effect of these tidal forces is to squeeze the oceans and produce two tidal bulges on opposite sides of the Earth, one facing the moon and a slightly smaller one facing away from the moon. Due to Earth's rotation, the two bulges act like two expansive waves, continuously undulating around our planet. Topography causes variation. Mid-ocean, each tidal wave is just under a meter high, compared to the water level of the two troughs between them. However, the variation between high and low tide is very different from place to place. It can range from almost no difference to over 16 meters, over 50 feet. This is because the water in the oceans is constrained by the shape and distance between the continents, as well as varying ocean depths. As a result, the tides behave more like water sloshing around in an oddly shaped bathtub than in a smooth and even basin. In some places, the water flows freely and quickly, while in other areas, where the water has to pass through narrow channels, it moves more slowly. High and low, nearly twice a day. Tides are one of the most reliable phenomena in the world, and we know that they move in and out around twice a day, but not exactly. So why is that? A day on Earth is the time it takes our planet to spin once around its own axis in relation to the sun. This is known as a solar day, and it lasts around 24 hours. However, the time it takes Earth to reach the same position in relation to the moon is, on average, 24 hours and 50 minutes, known as a lunar day. The reason the lunar day is longer than a solar day is that the moon revolves around Earth in the same direction as Earth rotates around its axis, so it takes Earth, on average, an additional 50 minutes to catch up to the moon. Because the tidal force of the moon is more than twice as strong as the sun's, the tides follow the lunar day, not the solar day. It takes half a lunar day, on average 12 hours and 25 minutes, from one high tide to the next, so we have high and low tides nearly twice a day. According to the National Ocean Service, there are some exceptions to the main rule of two tides every lunar day. Along the coastline of the Gulf of Mexico, there is only one tide per day due to the local shoreline topography, among other things. This tidal cycle is called a diurnal cycle, as opposed to the normal semi-diurnal cycle, where diurnal means daily and semi means half. Continents affect tidal lag. While in theory, the tidal bulges follow the moon's position on its orbit around the Earth, the depth and shape of the ocean and the distance between continents are also important in determining when the tide rolls in and out. The time that passes between the passage of the moon and the onset of the high tide is called the tidal lag. In the Southern Ocean, where tidal bulges can move relatively freely, the tidal lag may be around 2 hours. On the other hand, the tidal lag in the North Sea, a part of the Atlantic Ocean bounded by continental Europe and the British Isles, can be about 2 days. The change from low to high tide is known as flood tide, while the change from high to low tide is called ebb tide. The technical term for the difference in water level between high tide and low tide is tidal range. The flow and ebb are gradual, so it is not accurate to say that a high or low tide lasts around 6 hours and 12 minutes. That is a quarter of a lunar day. The speed of the water flow varies during this period, and it also varies from place to place. The Rule of 12. Various people who have to consider the tides in their daily life, like sailors, fishers, and surfers, often use what is called the rule of 12th to calculate the expected water level. This rule states that in the first hour after low tide, the water level will rise by 1/12 of the predicted tidal range in any given area. In the second hour, it will rise 2/12, and in the third hour, it will rise 3/12. In the fourth hour, it will also rise 3/12. In the fifth, it will rise 2/12, and in the sixth hour, it will rise 1/12. The sequence to remember is 1, 2, 3, 3, 2, 1. So, let's say the predicted tidal range is 12 feet. In the first hour, the tide would rise 1 foot. In the second hour, it would rise 2 feet. In the third and fourth hours, it would rise 3 feet. In the fifth hour, the tide would rise 2 feet, and in the sixth hour, 1 foot. The astronomical forces that drive the tides can be predicted very accurately, and these predictions are published in local tidal tables. However, different weather conditions also affect the sea level, and may cause both lower and higher tides than expected. If there is a storm, the seawater level often increases. This is called a storm tide, and is caused by a combination of storm surge and normal tidal movement. Strong offshore winds can move water away from coastlines, exaggerating the low tide. At the same time, onshore winds may cause the water to pile up onto the shoreline, making the low tide higher than usual. High-pressure weather systems can lead to days with exceptionally low tides. In contrast, low-pressure systems may contribute to causing much higher tides than predicted. The average tidal range in mid-ocean is around 1 meter or 3 feet. However, in some coastal areas, the tidal range can be more than 10 times higher in the most extreme regions. To give an average for tidal range along the world's coastlines doesn't make much sense, as they vary so much from place to place. The world's highest tide is in the Bay of Fundy in Canada, where the difference between low and high tide can be up to 16.3 meters, 53.5 feet. The highest tides in the U.S. can reach 12.2 meters, 40 feet, near Anchorage, Alaska. Along the coast of the UK, the tidal range varies from as little as 0.5 meters, 1.6 feet, to a maximum of 15 meters, 50 feet. Spring tides. The moon phase also plays a part in the tidal range. The greatest difference between high and low tide is around new moon and full moon. During these moon phases, the solar tide coincides with the lunar tide because the sun and the moon are aligned with Earth, and their gravitational forces combine to pull the ocean's water in the same direction. These tides are known as spring tides, or king tides. The name has nothing to do with the season spring, but rather it is a synonym for jump or leap. An equinoctial spring tide is a spring tide that coincides with either the March equinox or the September equinox, when the sun is directly above the Earth's equator. These spring tides usually have an even greater tidal range. Several times a year, the full moon or new moon happens as the moon is around its closest point to Earth, called perigee. This is popularly known as a supermoon and leads to even larger variation between high and low tides, known as perigean spring tides. However, the difference from a normal spring tide is only around 5 centimeters or 2 inches. The opposite happens when the full or new moon is around its farthest from Earth, apogee, also known as micromoon. The apogean spring tides are around 5 centimeters, 2 inches, smaller than regular spring tides. The tidal range is smallest around the quarter moons/half moons because the gravitational force from the moon and the sun counteract each other at these 2 points of the lunar month. These tides are called neap tides, or neaps, from Anglo-Saxon, meaning without the power. Neaps always occur about 7 days after spring tides. There is a difference between having noticeable tides and having true tides. For tides to be noticeable, the body of water has to be huge, like an ocean. Even though true tides also occur in smaller water basins, like big lakes, the tidal variations here are too small to notice. For example, in the Great Lakes in the U.S., the largest tidal range is less than 5 centimeters or just under 2 inches. Different weather conditions, such as wind and barometric pressure, creates bigger differences in the water level than tides on these lakes. This is also the case in the Baltic Sea, the Black Sea, the Caspian Sea, and even the Mediterranean. Many rivers connecting to the ocean do have high and low tides. In some of these tidal rivers, the water drains away almost entirely at low tide, making it possible to walk across the bottom of the river. If a part of a larger river is affected by the tides, The section affected is known as tidal reach. In a few areas, where the tide comes into a narrow bay or river, tidal bores can form. Created by the incoming tide, tidal bores are waves which travel against the direction of the water current. If you enjoyed the video, please give it a thumbs up and don't forget to subscribe to the channel. And it would be great if you could share your thoughts in the comments.